Hi everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. Vampire Survivors offers multiple player characters from the players to choose from, each with their own unique weapon and stats. This encourages the player to unlock and try out all the available characters. In addition to these characters, the game also includes pickups that can be found scattered throughout the map or dropped by props and enemies. These pickups include experience gems, gold coins, and various boosts such as the vacuum, which collects all experience gems on the map, and the rosary, which basically just kills all nearby enemies. In this part, we'll be discussing both characters and pickups as they are closely related. We will cover how to create characters and various types of pickups. This will include a leveling system and a way to damage the player characters. And by the end of this part, you should have something like this, which is characters, different types of pickups, a leveling system, and a way to damage the player characters. And without further ado, let's begin. The first thing on our list is to create base stats for the characters. And as mentioned in the previous part, we'll be using scriptable objects for anything relating to this. Now, if you are unfamiliar with scriptable objects or haven't been through the previous part, I highly recommend you check that out for more information before continuing on, as I won't go into detail as to what scriptable objects are because they are kind of redundant as I mentioned them in the previous part. So I will just assume that you already have a basic understanding of them. As with the enemy and weapon stats, to store the stats for our player character, let's create a new C# script called character scriptable object under the player subfolder in scripts. This script can be used to create stats for various characters in the game. Now that we've created the character scriptable object script, let's open it up and define some stats for our player character. It's worth noting that the actual game does have a larger number of stats to consider, but for the sake of simplicity, we will only be focusing on a few key stats in this part. First up, we don't want to derive from mono behavior, so change that to be scriptable object, and within here, we just want to create stats for the player character, the properties as we've discussed in the previous part. If you're not sure what I'm talking about, please refer back, and a create asset menu attribute and define it to suit this particular script. Back in your editor, you want to create a new subfolder under scriptable objects and call it characters. When you right click and hover over create scriptable objects, you should now see that there is an option for creating a character. So in there, create a new character scriptable object and name it whatever you want. So I know this is not the most descriptive of creative name, but I'll just name mine as knife character since I want this character to start off with a knife weapon. Since we now have the character scriptable object script, we can remove the move speed variable from the player movement script and reference the move speed here instead. Back in the editor, make sure to assign the knife character to the character data slot and set the speed to be your previous movement speed. As mine was 5, I'll set it as that. You may have noticed that we have not yet defined any experience or level stats for our player character. Now I decided to keep these stats in a separate script because we technically don't need a permanent record of the player's experience and level. So to keep these stats separate and more flexible, we will create a new script called player stats under the player script folder. This script, similar to the enemy stats script, will be used to store the player's current stats and manage them as needed. Open the script and let's begin creating and assigning the current stats of the player character similar to how we did so for the enemy. We just need to create a reference to our character scriptable object, current stats, and assign those current stats in the awake function. Once that's done, head back into your scene and add the script onto the player. Be sure to set the character data slot to be a newly created scriptable object. Now, let's create a system that allows the player to gain experience and level up. I'll be covering two approaches, a simple method and an advanced one. The reason for presenting both methods is to show different concepts and how they can be modified to your needs. However, I'll be using the advanced method going forward, so I do recommend you following that approach, but feel free to just watch whichever you want. Because if you prefer the simple method, you should still be able to follow the rest of the tutorial along without any issues, but you may need to change/omit some things. So both methods follow the same principle. We increase the player's experience based on the amount granted by the experience gems. When the player's experience exceeds the current experience cap, we increase the player's level, reduce the experience by the experience cap, and increase the experience cap, as it should become progressively more difficult for the player to reach the next level. So you must be wondering why we reduce the experience by the experience cap rather than just resetting it. Now this is because we want to carry over the excess experience to the next level. So for instance, if the player receives a large amount of experience above multiple levels, it won't just be reset to 0 once they reach the next level. Yeah, it just doesn't make sense and it isn't fair. So how do these methods differ? So these methods differ in how the experience cap increases per level. The simple method simply increases the experience limit by a fixed amount for each level, while the advanced method uses a system similar to that of Vampire Survivors. So what is the system that Vampire Survivors uses? Well, it is just this. And to summarize what this is, so it basically just says the level cap increases differently depending on the player's current level range. With that being said, you can now choose to continue for the simple method or skip ahead to the advanced method. Okay, so if you stuck around, you want the simple method. So for the simple method, start by creating 4 public integers. Experience to track the experience the player has for that specific level. Level to track the level of the player. Make sure to initialize it as 1 as we want our player to start off at level 1 and not 0. Experience cap to define the maximum experience for that level. Make sure to initialize this as your starting experience limit such that the player doesn't level up immediately on the first level upon gaining experience. And then we need an experience cap increase to define the increase in experience cap for every level. Next up, we have to create a function called increase experience with the argument of int called amount. Now we need to increase the experience based on how much is desired. As you might have guessed already, this function will be called by other scripts to increase the player's experience as needed. Afterwards, we need to create another function called level up checker, which will be called right after we increase the experience. This will check if the experience is more than or equal to the experience cap, and if it is, increase the level, reduce the experience by the experience cap, and increase the experience cap. This is a very simple yet smooth system. Head back into your editor and set the values to be something like this. This simple system for gaining experience and leveling up can be expanded and modified as desired. For example, you could change the way that the experience is calculated or increase the experience cap by a certain amount each time the player levels up. So as a specific example, if you want to double the amount of experience required to reach each new level, you could simply double the experience cap after increasing the player's level. This would also eliminate the need for an additional variable to track the experience cap increase, since we're basically just doubling it each time. Now do keep in mind that these are just suggestions and you're free to implement the leveling system in a way that best fits your game. Because at the end of the day, this is just a tutorial series and you don't have to follow everything to the bone. So now on to the advanced leveling system. For the advanced system, start by creating 3 new public integers. Experience to track the experience the player has for that specific level. Level to track the level of the player. Make sure to initialize it as 1 as we want our player to start off at level 1 and not 0. And an experience cap to track the maximum experience for that level. We then want to create a nested class within the player stat script. If you're not familiar with nested classes, they are simply classes defined within another class. And while technically you could create a separate script for this class, defining it within the player stat script also helps with encapsulation and readability. Thus, it's a nested class. Inside the level range class, define 3 integers: start level to set the starting level of the range, end level to set the end level of the range, experience cap increase to define the increase in experience cap for that level range. Before the level range class, let's also add an attribute called system.serializable. And what this attribute does is it basically allows the class to be serialized by Unity, meaning its fields are visible and editable in the inspector and can be saved and loaded from files. Without this attribute, the fields of the class will not be visible or editable in the inspector and will not be saved or loaded within the project. In short, the system.serializable attribute is just crucial for making the level range class and its fields accessible and persistent in the Unity editor. We also want to create a list of type level range that will store the different level ranges and their increases in experience cap. Now create a start function. Inside this function, you need to set the experience cap to the first experience cap increase value. Okay, so without this step, the player will start off with a 0 experience cap and will be able to level up immediately upon gaining experience. So this is very important. And next up, we need to create a new function called increase experience with the argument of an int called amount. Now we need to increase the experience based on how much is desired. As you might have guessed already, this function will be called by other scripts to increase the player's experience as needed. After increasing the player's experience, we need to create a function called level up checker, which will be called right after we increase the experience. This function will be called to check if the player's experience is greater than or equal to the current experience cap. If it is, the player's level will be increased and their experience reduced by the experience cap. The function will then determine the current level range and increase the experience cap based on that range. Head back into the editor and set the values to be something like this. And before we end off this section, be sure to set the level ranges correctly. Avoid setting overlapping levels or missing any levels. And as a tip, if you don't want to change the experience cap increase after a certain point, for instance like at level 50 you don't want to increase the experience cap anymore, you can just set the end level to a very high number such as 99999 because it should be virtually impossible for the player to get there. Now that we have a system for gaining experience and leveling up, we can start creating experience gems for the player to collect. However, before we begin, it's important to think about the purpose of these gems and how they will fit into the game. To better understand our goals, let's take a step back and analyze what we are trying to achieve. This will help us to better plan out the implementation of the experience gems. So in Vampire Survivors, experience gems are dropped by enemies a certain percentage of the time. These gems come in different colors, each with a different experience value and are spawned based on the enemy that dropped them. Thus, if we put all this information together, we now know that to implement this system, we will need to create a drop rate manager for enemies that allows us to spawn the appropriate experience gem and set their drop rate. So let's begin by creating the experience gem prefab. To begin creating the experience gems, download the gem icon spreadsheet from opengameart.org that I found and drag it into your art folder. Rename the file to gem spreadsheet. Before slicing the spreadsheet, set the pixels per unit to 32 by 32 and then use the automatic preset for slicing. Let's drag the blue gem sprite from the spreadsheet onto the scene. Name it blue gem and set its sorting layer to foreground so it appears in front of the map. Don't forget to reset the transform as well. Next, create a new subfolder under prefabs called pickups and drag the gem into it and create a prefab. Then, delete the existing blue gem from the scene since it's no longer needed. Now, create a new script called drop rate manager and open it up. Inside, let's define a nested class. Now inside the drops class, define three variables. Name to define the name of the drop, item prefab, a reference to the prefab of the item that will be spawned, drop rate, a float value representing the chance as a percentage that the item will be dropped when the game object is destroyed. And then we also want to create a list of type drops that will store the drop rates for all the different items that can be dropped. Add an onDestroy function to your script. If you don't know what this does, this function will be called just before the object it is attached to is destroyed, allowing us to spawn the dropped items. And by using this method, you can see that we can make this script self-contained and easily attach it to other game objects that drop items without the need for any dependencies. So what I mean is we can just attach this script without any strings attached and just modify it in the inspector. So inside the onDestroy function, we need to do the following. So let's use random.range to generate a random percentage between 0% and 100. Make sure to specify use of Unity Engine's method as your code editor may default to using another random number generator. Let's then iterate through the drops list with a for each loop and check if the random percentage is less than or equal to the drop rate of each item. And then if the random percentage meets this condition, let's use instantiate to create a new instance of the item prefab at the position of the destroyed game object. So to better understand how this system works, let's just consider an example. For instance, if a drop rate of an item is 25%, the item has a 25 chance of spawning. When random.range generates a random percentage, if that percentage is less than or equal to 25, the item will be spawned. So yeah, it's just as simple as that. Add the drop rate manager to the bat prefab. And now, when you add and expand the element, you should see the multiple parameters appear. Great. So let's add in the blue gem that we created into the parameters and set the drop rate to 50% as a test. Now, when you hit play and destroy the enemy, you should see that the blue gems drop 50% of the time. However, I don't know if you've noticed, but there's a slight problem with this. Currently, if we have 2 or more items on the drop rate manager that matches the spawning conditions, all of them will spawn instead of one item. For example, if 2 items both have 100% drop rate, both of them will spawn. Now, the problem happens because we haven't made it such that only one item will be chosen even if 2 or more meet the condition. So to fix this, we basically want to create a new list that contains the possible drops that we can get and then randomly choose one of them to spawn. Okay, so basically what we are doing here is checking for possible drops that can be spawned and randomly choosing them. You can feel free to modify the selection process however you like. For instance, if you want to spawn the rarest item, you can check for the item with the highest drop rate. Okay, so before we wrap up this section, it is important to note that the drop rates of all items should not be more than 100, as it is impossible for an item to have, above a drop rate of 100%. Remember to double check your drop rates and make sure that they are set up correctly, unless they will cause an error. We now have a way for enemies to spawn experience gems when they are killed. Let's create a system that allows the player to collect the gems and increase their experience. One way to do this is to create a new script with an onTriggerEnter2D function that increases the player's experience when they collect with the gem. However, let's do a bit more work so that we have a more flexible universal collectible system. There are many ways to create a collectible system, such as using inheritance to derive the collectibles from a parent class. However, this method is only suitable for when collectibles have similar functions. And since collectibles often serve a variety of functions, such as providing health, coins, and boosts, it will be better to use a more modular approach. So one option is to use interfaces to define a set of related methods that a class must implement. And by creating an interface for collectible items, we can just pretty much just create a common set of methods that must be implemented by all collectible items, meaning that the collectible item scripts have to contain these methods. So this allows us to define the behavior of the collectibles in a more organized and flexible way. And the big advantage to using interfaces is that unlike inheritance, an interface allows us to implement them multiple times in a single class, unlike inheritance, which only allows us to inherit from one class. So to get started, let's create a new folder in the scripts folder called interfaces, and then within it, create a new script called iCollectible. We prefix it with I as a way to distinguish interfaces from other classes, so we don't get confused what is an interface and what is not. So to turn the script into an interface, we will just need to remove everything within it, change the class to be interface, and add a new function called collect that can be changed in the scripts that implements this interface. Now create a subfolder in the scripts folder called pickups, and inside this folder create a new script called experience gem. Within the script, implement the iCollectible interface like so. You should see that the iCollectible has a red squiggly line under it, meaning that the interface has yet to be implemented. To implement the iCollectible interface in the experience gem script fully, you can either hover over it and click show potential fixes and then implement interface, or you can simply add in the method by yourself. Let's now remove everything in collect. Create a new public int called experience granted to determine the amount of experience the gem should give. And inside collect, let's create a reference to the player stats and increase the experience based on the experience granted. And obviously we need to destroy the gem after it is collected since we don't want to pick it up multiple times. Now let's add a circle collider 2D to the blue gem prefab and set it to be a trigger. Then attach the experience gem script and set the experience granted to be something like 100. To allow the player to collect this gem, create a new script called player collector in the player scripts folder. In this script, we'll include an onTriggerEnter2D function. Within this function, we can use the tryGetComponent function to check if the other game object has the iCollectible interface. If it does, we can simply call the collect function on it. You can also reference the iCollectible and check if it is now, but I find that this method is easier. So if you're wondering why we're creating a new script for this instead of just calling onTriggerEnter2D on the experience gem itself, it's because that gets tedious very fast. For instance, if we have a lot of pickups, because right now we only have experience gem, but let's say if we have a health pickup and several boosts, and we need to keep checking onTriggerEnter2D for each of these scripts, it would just be better to have one script that just checks for every other collectible instead of multiple scripts checking for one player. To end off this section, make sure to attach the player collector script to the player's character and set the blue gem's drop rate to 100% for testing. Now when you press play, the player should be able to collect the gem and gain experience. Congratulations, you have successfully created a universal collectible system using interfaces. To conclude this part, let's modify our player so that they take damage when hit by an enemy and create some health pickups to heal the player. Let's create a function in the player stat script that allows the player to take damage when an enemy hits them. This function will use the same concept as the function we created in the enemy stat script for the player to deal damage to the enemies. So inside the player stat script, let's create a function called take damage that accepts a float called damage as an argument and another function called kill. Inside these two functions, we can do the same thing as we did in the enemy stat script. But instead of destroying the player object when the health reaches 0, let's use the debug.log for now. In the enemy stat script, we can use the onCollisionStay2D function to continuously damage the player as long as their colliders are in contact. So this is opposed to using the onCollisionEnter2D, which will only damage the player once upon initial contact and not again until the player moves away and re-enters contact with the enemy. And obviously we are using collision instead of trigger since both the player and enemy colliders aren't triggers. Back in the editor, set the knife of the knife character to be something like 100 and the damage of the bat enemy to be something like 30. We can then disable the knife and the weapon controller for testing and set the inspector to be in debug mode so that we can see private variables. To do this, click the three dots in the top right corner of the inspector and select debug. You should now be able to see the private variables. And when you play the game and allow the enemy to hit you, the current health should go down and you should get the debug message after the player's supposed death. However, currently there is a problem where the player takes damage too quickly. So to fix this, we can implement something called invincibility frames or iframes. In video games, iframes are basically a time unit during which a character cannot be hurt. This usually happens after the player is damaged, so they don't take continuous damage, which will be unfair. In our player stat script, we can create variables to begin putting this system together. First up will be a public float called invincibility duration to set the duration of invincibility after taking damage. Next will be a float called invincibility timer to track the current invincibility time. Last but not least will be a boolean called isInvincible to check if the player is currently invincible, means whether or not they are immune to damage. So inside the take damage function, we can check if isInvincible is false before running the function. And after the player receives damage, we set the invincibility timer to the invincibility duration and set isInvincible to be true, which will make the player immune to damage. In the update function, we can check if the invincibility timer is above 0 and reduce it constantly. And if the invincibility timer is not above 0, it means that the player is not immune to damage and we should disable isInvincible. So this system makes it so that the player can only receive one instance of damage at a time. Before hitting play, let's set the invincibility duration to 0.5 and the health of the knife character to be something more reasonable like 1000. When you hit play, you will notice that the player only receives damage every 0.5 seconds. Great! Before we wrap up this part, let's create a way for the players to break props and receive items from them. In Vampire Survivors, players can obtain various drops from destroying props, such as coins, health items, and boosts. So for now, let's focus on the health items that are the most commonly dropped by props, and we can reuse the drop rate manager that we previously created to spawn them. To get started, let's create a new script called Breakable Props. And here's what we need to do. Now let's head into both our projectile weapon behavior and melee weapon behavior scripts to create some code for the weapons to do damage to the props. But we're not quite yet done. Now if you recall back in the previous part, we actually overrode the onTriggerEnter2D inside of the Garlic behavior script. So we basically have to modify that script as well. As you can see, we are basically treating the props as enemies and adding them to the marked enemies list such that we don't continuously damage them with the garlic as well. Now back in the editor, create a new tag called props and apply them to all, props. And then place the breakable prop script on those props that you want to be breakable and set their health to be something like 10. When you hit play and test, the prop should now be damageable by the weapons. So the last thing we have to do is to create a health item for our player to pick up and heal. Download the Pixel Potion sprite sheet that I found once again on opengameart.org and rename it to Potion Sprite Sheet. Make sure to set the pixels per unit to 32 by 32 and then use the automatic preset for slicing. Drag out the red potion, you can just drag out any that you want, but I'll just drag out the red potion and rename it to, just red potion. Afterwards, reset its transform and make it a prefab. You can then delete the existing red potion on the scene. We can then create a script called health potion and implement the iCollectible interface to fit all our needs. Now let's head into the player stat script to create the restore health function. So this is fine, but let's add some extra features to ensure that the player can only restore their health if it is below the maximum. And if the player's health is restored to a value above the maximum, we will just set it basically to be the maximum. In the editor, attach a box collider 2D and the health potion script to the red potion prefab, and set the amount to heal to be 100. Then attach the drop rate manager to all your breakable props and add the red potion prefab as a drop with a 50% drop rate. To test the system, let's disable the enemy movement on the enemy. And when you hit play, you should be able to see that destroying the props has a 50% chance of spawning the potion. When the character's health is not at the maximum, just damage ourselves with the enemy here since it's easier because the enemy movement is disabled. And yeah, so when the player picks up the potion, their health should be restored. And if their health is already at the maximum, it will not increase past the maximum. Awesome! That's all for this part. In this part, we went through how to create characters and pickups. This included a leveling system for player characters and also a way to damage them. I hope you all enjoyed the video, and if you want to support what we do, you can actually help us by becoming a Patreon. This will give you access to the project files for tutorials, like this one, as well as any Patreon exclusive posts on our blog. You can find the link to this in the description below. Any support that you give us will actually go a long way. because currently we are making back about 20 cents for every single dollar that we put into content creation. So your help will actually go a long way to help us make this a sustainable endeavor. So that's all. I'll see you all in the next part. Bye.